So, we will see the problem intersection point of two linked list. Assume there are linked list, two linked list L1, that is 1, 2, 3, 4 and 5. There is another linked list L2 with elements 5, then directly 5 is linking to 4, okay. 5 is linking to 4. There are two lists like this, 1, 2, 3, 4, 5, other one is 5, 4, 5. It means this 5 node is linking to this, 5 should not repeat, no, let us put 6 here, like this. So, this 5 is connecting to this 4 in between, right. So, let us implement this and see. Logic is very simple. What is the logic of doing here? See, find out, it is very simple. I will quickly give an overview here. Length of L1, what is the length of L1? It is 5. Same way, length of L2, it is 3. Difference is, take absolute difference is 2. Now, when you get the difference is 2, whichever is maximum, whichever list is maximum, okay, we know L1 is maximum. In L1, in list L1, traverse d number of nodes, that is difference number of nodes. So, what does it means? It means d, what is value of d here? Value of d is 2. So, traverse 2 nodes, and this 3 you make as your head. After traversing 2 nodes, 3 becomes head of L1. Now, this is what you have to do. Whichever list is larger one, that list you have to traverse. How many nodes you have to traverse? You have to traverse 2 nodes. So, you will reach the third node. Your current pointer will be at third node. So, L1's list L1, its head is at 3 location. L2 head is as usual 5 location. Okay. So, 5 is the head of L2. Now, L1 pointing at 3, L2 is pointing at 5. From here, you just move forward. Every time you compare this 3, this 5. Compare. How to compare this? Simply write if L1 means that is head 1 of data is equal to head 2 of data. This you check. Where is head 1? It is at 3. Where is head 2? It is at 5. Compare these two data. Is 3 and 5 same? No. If this is the case, then you print it. Otherwise, if this is the case, you have to just print. You have to give C out head 1 or head 2 of data. Anything you can print, either head 1 or head 2. Else case, what you have to do? You have to just head equal to head next. Head equal to head next. So, you will move to next location. Same way, head 2 equal to, okay, that is it. So, what I am doing here? First I am traversing 2 nodes. How did I find that 2 node? That is by difference of length of 2 linked list. Then head 1 is pointing at 3, head 2 is pointing at 5. Compare 5 and 3. No, they are not same. So, what does when they are not same, you have to move forward. So, head 1 is pointing to 4, head 2 is pointing to 4. Compare, are they both same? Yes, that is the intersection point. This is the logic of finding out the intersection of 2 linked list. So, first we have to create this list and then we have to implement it. Let us try to see whether you are getting the expected output or not. I hope you understood the logic how to solve this. So, I am deleting this. So, we have to use IO stream, then I will use stdlib because I am using malloc function, then using namespace std and then struct node int data and struct node star next, because single linked list I have to create it like this. Now, this is the, how many lists do I have? I have 2 lists. So, I will initially create 2 heads head 1 equal to, I will put it null, I will create another node. I am creating empty list, okay, I am creating empty list like this. Now, why head 1, head 2? Because there are two lists, this is L1, this is L2, okay, L1 and L2. Next what I have to do, I have to write a function to insert new element. How do I insert new element? Insert node of, I have to write int some x, okay. We will come to this, I will write the logic, let us write int main for us. Int main, here we have to call this function int node. See, but when I call int node, I have to pass the head also. What head? See, when you are inserting an element, for which head? Is it for L1 or is it for L2? That you have to clearly specify. For that reason, we will be sending the head information also. Let us, for now, let us assume I am creating for head, that is head 1 only. So, I will put it 10 here. Before this, I have to create struct node some variable head, let it be null, okay. Then I am passing this with 10, again I will create this with 20, again I will create this with 30 and 40, 30 and 40, shall we take one more? Yeah, let's take one more, 50, right. So, I have created a list now, with these where the head is this variable and the elements are 10, 20, 30, 40. So, I am passing head also here. So, here definitely I have to receive that head, struct node star ampersand head, because I am sending the address, no, I am sending the, this is a pointer, so I am sending the variable, I have to receive the address of that, okay. So, this way you can, now what to do, you can write here struct node star head 1 equal to your head, okay. This is why whatever list I have created till now here, that I am pointing it as head 1, that I am naming it as head 1, okay. Now, you have to create a temporary pointer. Why? See, this is my list 10, 20, 30, 40 and 60. Let me put 60 here, okay. Now, this is the one. Now, this is 50, 40 and again 60. So, which one is a common point here? 40, no? This 40 I want to link here. So, let me create list 2 first, okay. Let me create list 2. So, again I will write this function, insert node, I will pass here head 2, I will pass here some head 2 with first element as 50. Then I need not create other two elements. Why? This 40, 60 or these two 40, 60. So, simply I have to map this node, that is head 2, its next, it should map to which element? Head 2 is this is list 2. List 2 I have added a new element only 50. List 2 I have added only one element 50. List 1 how many elements I have created with head 1? 10, 20, 30, 40, 60. So, this element, this head 2, that is 50, 50's next should be 40. How do I get 40? How can I get the 40's address? For that you will create another temporary pointer, temp, okay, where temp is equal to head 1, okay, head 1, no, yeah, here temp 1 equal to head 1, this is fine. Then temp equal to temp of next. See what will happen? Temp is at 10, temp next means 20, its next means 30, its next means 40. This way I got the address, this variable temp contains the address of 40. So, I will say head 2's next is this temp, head 2's next is this temp, okay. This way what I have done here now, I have created these two lists, okay. Anyhow, we have to write this logic yet, but I have just created template here. I am having a function insert node, I am passing the head, that is head 1. So, head 1 will have the elements 10, 20, 30, 40, 60 and head 2 will have 50 and it will immediately point to this 40, it will point to this 40. So, with this we created that what we say chain, okay. Now, we will go and write the logic of insert function. How do we insert elements into the list? So, I think you are aware of this. We have to write the basic no thing star new node equal to in bracket struct node star malloc size of struct node, right. This is a fixed statement to allocate memory. Then new node data equal to this variable x which we are passing, that I will put it here. Then new node its next will be null, this we already know, right. So, these 3 lines will create a new memory block and it will assign value x to the data part and null in the next part. Now, I will make my brief check, that is if head is equal to null, which is this head, the head which is received here. If that is null, when we have an empty linked list, what we have to do? We have to make that new head as new node, right. Simply head equal to new node. I think we have already studied this to insert an element in a at the beginning. When the list is empty, we do this check. Okay. Next, else what I have to do? It means there are some elements in the list. There are some elements in the list. So, I will take a temporary pointer, because I have to traverse, no? I have to traverse till the end of the list. So, node star temp equal to the head which I have received. It can be any head, whatever head I am passing, that only it will worry about. So, I got my temp now. So, I will go while temp next not equal to null. Why is this? We are well known of this now. We have to traverse to the end of the list and add the element. So, we are kind of implementing adding an element at the end. Okay. So, what I have to do? I have to write temp equal to temp next. So, what these 2 lines will do? It will take me to the last node of the current existing linked list. Now, my while loop is over. What I have to do? Simply write one statement, temp next equal to new node, that is it. One line is enough. This line will add the element at the end. This line will add the element at the end. Okay, right. So, that is it. If you are confused here, let me put bracket like this in while loop. Let me delete this here this way, right. So, this while loop is useful for me to iterate to the last node of the list and then add the element at the end. Okay. So, this function is sufficient to add an element in the list. So, insert node, I am passing the head as well as the variable which I want to add. This will insert the element. If there was no element, these 2 lines will execute. If there are elements, then this will execute. Okay. Let us write the display function also, void display. Since there are 2 lists, I want to display both of them. So, I have to pass the head also here. So, let me write cout elements of list 1, okay, and I will call the display function with head as the value, head 1 as the value. So, this will display me the elements of head 1. Again, I will write elements of list 2 with head as 2. Okay. Let us see whether it is inserting and whether it is printing. Let us implement this display function. It is very simple. Take the temporary pointer which should point to head. Then what I have to do? I have to iterate while this while loop. This while loop is sufficient. Okay. Here while loop, while temp next not equal to null, cout temp of data and L. So, in this code is sufficient to print the value, okay, the elements. Let us see now whether this will execute and create me 2 linked list, with one with 10, 20, 30, 40, 60, other one with 50, 40, 60. Okay. This code, let me check if it is working. Okay. Intersect, today is 0609. Some mistake, void display. Oh, we have to pass head right here. So, struct node star ampersand head. Okay. This thing we missed because the head is not known. End was not declared, end L, sorry, end L, right. Yeah, see, elements of list 1 10, 20, 30, 40, element of list 2 50, 40. Why one more element is not inserted? 10, 20, 30, 40, 50, 40, 50. Any mistake? Why is it not inserting elements? Is display failing? Okay, display may be failing. Temp next, I think this is the case, if temp not equal to null. Yeah. No. Oh, sorry, this is not the case, no. Here we have to change. This is display, yes. Yes, see, I think you are able to see the output. Elements of list 1 10, 20, 30, 40, 60, element of list 2 50, 40, 60. Okay, so we got the list now. I think you are aware this thing we have achieved 10, 20, 30, 40, 60 and 50, 40, 60. Okay, now we will write the actual logic, no, that is finding out the intersection point. So let us write a function for that, for the intersection point. Maybe void only, void intersection, and I have to pass both the heads. So it is struct node star ampersand head 1 and struct node star ampersand head 2. I will be passing both the heads. Now what I have to do? I have to find out the lengths of both the list and difference also. So int d comma L1 equal to 0, length 1 comma L2 equal to 0 initially. Now what I have to do, first step is to find out length of both the list. What was the logic? I will repeat once again. What was our solution? Find out the length of L1, find out the length of L2, find out their difference. After finding out difference, whichever list is large, that list you traverse it difference number of nodes. That list you traverse difference number of nodes. Once you traverse difference number of nodes, from there have a common check. Compare if head 1 data is equal to head 2 data, print and break. Okay. So I have to calculate the length. Length of, how do you calculate length? Again same thing. While temp temp next, okay, temp next not equal to null. What I have to do? L1 plus plus and temp equal to, but here we are having two lists, so I have to create two temporary variables. So let me create struct node star temp 1 equal to head 1, same thing, struct node temp 2 equal to head 2. Okay. So this will be my temp 1 because I am trying to find out length of L1. Same thing I will repeat again. This is for list 2, temp 2 next not equal to null, L2 plus plus. So temp 2. So this logic will try to give me the length of L1 and L2. Then find out the difference. What I have to find out? See, I have to find out the positive difference. How do you find out positive difference? D equal to, you have to use absolute function ABS of L1 minus L2. Since we are using ABS, we have to include the header file math #include math.h. Okay. So absolute difference I got. Now what we have to do? You have to check if L1 is greater than L2. If L1 is greater than L2, then it means list 1 is great. Okay, list 1 size is high. Then you have to iterate how many times? D number of times you have to iterate. So I will write here while D minus minus while until d becomes 0, you can put head 1 equal to head 1 next, head 1 equal to head 1 next. This is for no iterating the head 1. Okay. Same thing we have else for this if the L1 is greater than L2, this part. For this, if I have else, what is my else here? Again, while d minus until d is 0, head 2 equal to head 2 next. So with this, if this is true, head 1 will move to this location, that is to 30. If L2 is large, it will move to that location. That way this will do. Okay. So till here I think if open and close, yeah, this is done. Now once you came to that location, simply put one if condition. What is that if condition? That if condition is if head 1 data is equal to head 2 data, then right, if head 1 data is equal to head 2 data, then here you have to return, or we will print cout head 1 data, or you can print head 2 data also, no problem. Why? Because both are same, no, both are same, NDL. Okay, this you can do and you can break the condition. Else what you have to do? Else is not required. If they both are same, only this. But see, this is okay, one time check. What about next element? If they are not equal, what I have to do? I have to use one while loop here. While head 1 and head 2. Why? Because if anyone is null, we have to stop. If anyone is null, we have to stop. So inside this while only I have everything, this part. So if both are equal, do that. Else what I have to do? Simply you have to move forward. Head 1 is equal to head 1 next. Head 2 equal to, because we are comparing, no, head 1 data is equal to head 2 data. If they are not equal, move head 2 next, head 1 to next pointer, move head 2 to next pointer, again compare. Okay, equal to head 2 next. Okay, I think this should suffix. Let us run this and see whether it is giving the common point. I will write here some message, the common the intersection point is like this. Let us execute this and see. Okay, I have to call this function here, right? What is this function? Intersection of head 1 comma head 2, that's it. So let's execute. See, we got 10, 20, 30, 40, 60, 50, 40, 60, the intersection point is 40. Okay, I hope you understood the logic here. If I change the numbers 10, 20, 30, 40, let me add more numbers. So list 1 has 70 and 80. Okay, see the output here. Elements of list 1 10, 20, 30, 40, 60, 70, 80. Element of list 2 50, 40, 60, 70, 80. The intersection point is 40. Why it is coming 40 always? Because we have given temp equal temp next, right? So this is the implementation of finding out the intersection point of two linked list.